Lesson 3.1, Graphing Linear Equations. Our essential question is, how do you identify the X and Y-intercepts of a linear equation? We're going to learn 3 new vocab words today. The first one is standard form. Standard form for a linear equation looks like this. And we use standard form to find the X and Y-intercepts and then draw the graph for an equation. So this is a second method for graphing. Instead of making a t-chart where we plug in values for X and solve the equation for Y, we are going to find the X and Y-intercepts and use those 2 points to graph our line. The X-intercept is where your graph crosses the x-axis. And similar to that, the y-intercept is where the graph crosses the y-axis. The word intercept is very close to the word intersect. So you can think of your line intersecting the x and y axis, and we're just finding the values for those points. Okay. Our question is, what are the rules for writing an equation in standard form? Standard form is very picky, very specific. I like to think about the ways that you can write an equation for something that is linear. I like to think of them as like writing your name in a specific way. Sometimes you're asked to write your first name and then middle and then last. Other times you might need to write your last name and then a comma, your first name, and then middle initial. So it's very specific. A, B, and C. A, B, and C are not variables. A must be a whole number, 0, 1, 2, 3, and so on. B and C are integers. So that means that they could be positive or negative. This means no fractions are allowed and no decimals are allowed. So no fractions, no decimals. So A, B, and C. A is a whole number. That means that it's positive only. B and C are integers, so they could be positive or negative. Okay. Here are 6 examples. And the question is, are any of these written in standard form? And if they're not written in standard form, you should be able to explain what the problem is. So the first one is not in standard form because A is negative, and that is not allowed. So remember our standard form, AX plus BY equals C. And we could say A has to be a whole number, B and C must be integers. And the terms have to be in that order. Look where your equal sign is. A has to be with X plus B with the Y equals C, which is the plain number, an integer. The next one, I'm going to say no because 2 terms are in the wrong order. They're on the wrong side. So the 2 that are on the wrong side are the 2 and the 5y. The next one looks great. 3x plus 5y equals -2. So yes, this is in standard form. A is 3, B is 5, C is -2. So the order fits and the requirements for what type of numbers they are is perfect. The next one, no, all of the terms are on the wrong side. The next one, no, because A is a fraction. Fractions and decimals are not whole numbers. And the last one, yes, this looks good. A is 6, B is -3, and C is 11. Okay, so that is standard form. Now we are going to be using standard form a little bit later today. The next question says, how do you find the x and y-intercepts from this graph? Well, remember in our vocab definitions, we said an x-intercept is where the graph crosses the x-axis. Here's the origin, right here is the origin. So this is my x-axis, and then this is my y-axis. Okay, so this graph crosses the x-axis at 60, so my x-intercept is 60, and my y-intercept, where the graph crosses the y-axis, up here is 5,000. Okay, and then it says using the labels, what do the intercepts mean in this graph? Well, using the labels, so now I need to be looking at the axis labels. So we've got remaining balance and number of $85 payments. I also need the title, orthodontic payments, to help me make sense of the situation. So this 5,000, this y-intercept of 5,000, if that's the remaining balance, and that's after 0 payments, because I see that it's the intercept. So that means orthodontic payments, remaining balance 5,000. So I would say the original, balance, or the initial balance, starting balance, is $5,000 for orthodontic treatment. Then, if I look at the 60 on the x-axis, that's when the balance hits 0. So I would say after 60 months, of $85 payments, the orthodontist is paid off. So 1 is the starting balance, that's the y-intercept, $5,000 is how much you owe at the beginning, and then how long it takes to pay off that balance, 60 months. Okay, another problem similar to this. So x and y-intercepts from the graph. X-intercept is 14. Y-intercept, 10,000. And then looking at the labels, what do the intercepts mean? We're talking about draining a pool. We've got a volume and time. So at the top, when the pool was full, it had 10,000 gallons. I'm assuming of water. Then, at the bottom, 14 hours. After 14 hours, after draining for 14 hours, the pool was empty. So these last two examples are just showing how you can use a graph, find the intercepts, and then interpret the situation. Now we're moving on to a table. How do you find the x and y-intercepts from this table? Well, hopefully on the last two examples, you recognize that where the intercepts are, they're right on the X and Y axis. So I want you to think about any point on the axis and what one of those coordinates has to be. So any point on the x-axis. So if I just draw a little sketch and I put some points in that are on the x-axis, I want you to think about their coordinates. So if I put a point right here on the x-axis, that would be 1, 0. If I put a point over here, it would be 3, 0. Over here, -2, 0. So what those points have in common, if the point is on the x-axis, they have a y-coordinate of 0. So you can see that in the table. The y-coordinate of 0 gives us an x-intercept of -8. Similarly, if we graph points that are on the y-axis, like this point up here would be 0, 3, this would be 0, -1, and 0, -3. You can see that for the coordinates that are on the y-axis, any point on the y-axis has an x-coordinate of 0. So an x-coordinate of 0 would be right here. So that gives us a y-intercept of 6. So the key is that if it's an x-intercept, x isn't 0, y is. And if it's a y-intercept, y isn't 0, but x is. It's the other coordinate. One more table. Look for the zeros, magic number 0. So if x is 0, the y-intercept is 248. And down on the bottom, if y is 0, the x-intercept is 4. Now this one has a little bit more that it's asking of us. It says, using the labels, what do the intercepts mean in this table? Well, we've got time and we've got distance. So at time 0, the distance is 248. So what that means is that, the interpretation I'm going to take from this is that you have 248 miles to travel to get to your destination. So you have 248 miles to go to reach your destination. Because at time 0, that's when you're starting out, that's how many miles it says you've got. Then, after 4 hours, your distance is 0. So then I'm going to say, after 4 hours, you've reached your destination. Wherever that destination may be. Okay, now our last skill. Without a table, without looking at a graph, find the x and y intercepts from this equation and use them to graph the line. Well, we already found out that to find an x-intercept, we would plug in 0 for y. And to find a y-intercept, we plug in 0 for x. So I'm going to start with the x-intercept. So that means y equals 0. So I'm going to take my equation and put a 0 where the y is, like this, and then solve it. 5 times 0 is 0, so 2x equals 10, divide by 2, and x equals 5. So in my little T-chart, I can put x equals 5. Okay, now I need to find my y-intercept. So I can plug in x equals 0. So 2 times 0 plus 5y equals 10. 2 times 0 is 0. So 5y equals 10. I divide by 5. And y equals 2. So I can fill in 2 for y. So my ordered pairs, my x-intercept was x equals 5. So on the x-axis, I put a point at 5. My y-intercept was 2. On the y-axis, I put a point at 2. And then I connect them. So I need 2 points to make my line. I have the x-intercept and the y-intercept, and draw the line between them. One more example like that. So x-intercept again, I need y to be equal to 0. 3x minus 0 equals 6. 3x minus 0 is just 3x, so 3x equals 6. Divide by 3. 6 divided by 3 is 2. So x equals 2. So in my table over here, x equals 2. My y-intercept, x equals 0. So 3 times 0 minus y equals 6. 3 times 0 is 0. So 0 minus y, I'm going to put a 1 in front of here. So 0 minus 1y equals 6. So that means negative 1y equals 6. Divide by negative 1, and y equals negative 6. So y equals negative 6. Now I can graph my intercepts. The y-intercept is negative 6. So on the y-axis, I go down 6. The x-intercept is positive 2. So positive 2 on the x-axis. And then I draw my line. Make sure that you are graphing 2 separate points. 2 separate points. So this is not one ordered pair with an x-coordinate 2 and a y-coordinate negative 6. That's the most common mistake that we see. So 2 separate points, 2 separate ordered pairs. So this one was 0, negative 6. This one was 2, 0. Okay. You should be able to write a summary now and work on your homework.